Good afternoon. Welcome to Think Purple Math. Today's topic, or the topic for this unit or this lesson, is finding the slope given 2 points of a linear equation. There are some typical ways of doing this. There's a slope formula, and we're going to use that slope formula primarily for most of this unit or for this demonstration lesson. There's a couple of bullet points I always like to reiterate to kind of get us going. The first thing we're going to do is to label our points. Students often forget to do that, and that causes some confusion about what's number or what x value goes where and so on. So we're going to label our points. Second thing we're going to do is we're going to use the slope formula, and the slope formula is on the third bullet point, and M stands for slope. y2 minus y1 divided by x2 minus x1. If there happens to be a graph available, and we're going to do a couple of them where there's a graph available, we're actually going to use the rise over run method or the counting method from the graph itself. And we're not going to use the formula. We're going to simply, that only works if the graph has two distinct points that are precisely on a point. Then we can use the counting method. So the first step we're going to do, here's the first question. Find the slope of the line through those 2 points. You could pick any 2 points on the line and you'll get the same slope. So I have positive 1, negative 19, negative 2, negative 7. Alright, the first thing we're going to do is we're going to label the points, and I'm going to use red here. x1, y1, x2, y2. So we've labeled our points. The next thing we're going to do is we're actually going to write the slope formula down as we go. y2 minus y1 over x2 minus x1. The next thing we're going to do is we're going to create what's called what I call a template. We're going to set this up, and I always tell my students, put in negative signs, your minuses in right now. So I'm creating a template down below. And what that does is, in case there's double negatives, we'll be able to catch it right now. Sometimes if you forget to put the negative, then you may make an error. So now we're going to substitute in the numbers or the coordinate pairs one by one. First one is y2 or y sub 2. It's negative 7 minus y sub 1, which is negative 19. So I'm subtracting a negative, therefore I'm going to add a positive, plus 19, plus 29, I'm sorry. Oh, you're right. That is supposed to be a 19. My bad. There we go. Make a mistake, we fix it, no worries. X sub 2 goes first, negative 2, minus x sub 1, which happens to be 1. So now we do our arithmetic. Negative 7 plus 19 is positive 12, and negative 2 minus 1 is negative 3, and 12 divided by negative 3 happens to be negative 4. And I always remind my students, look, if you have a negative slope, whether it's a fraction or an integer or a whole number or what have you, put the negative on top. You could think of this as negative 4 over 1 if you'd like, but put the negative in the numerator. That'll come into play later. There's our negative 4. Alright, find the slope through these 2 points. Okay, we're going to speed up the process. We're going to stay in the same color here and not change. x1, y1, x2, y2. I'm going to write the slope formula next to it until we get it down memorized. Set up my template. I'm good to go. Y sub 2, negative 4. Y sub 1 happens to be 7. So we'll write it down as 7. So it's negative 4 minus 7 in our numerator. X sub 2, negative 6. Now here's where it comes into play that x sub 1 happens to be negative 4. We're going to change that to positive. So we do our arithmetic here. We get a negative 11 divided by a negative 2. And the negative divided by a negative will simplify. And our slope for those 2 points is 11, positive 11 over 2. And we check it. There it is. You can always pause the video at any time and take a look at my steps. If you happen to be one of my students, I will be posting these periodically, the hard copies. Create a PDF document and then upload them to either my personal website or on Google Classroom. Alright, we're going to do a couple more with the slope formula, and then we're going to a grid. And then we're in the conclusion, we're going to talk about some slopes types and what I call stating the directionals. So here we go. X1, Y1. Whoops. Let me make a correction there. X1, Y1, and X2, Y2. In this case, I'm not going to write the formula. We're going to do it by memory. So it's Y2 minus Y1, which is negative 17 minus a positive 3. And X2 is 19 minus positive 9. Negative 17 minus 3 would give us negative 20. And 19 minus 9 would give us positive 10. So we're looking at negative 20 over positive 10. And that reduces down to negative 2 for our final answer. So there's the slope of that set, negative 2. And there we are. Okay, find the slope of these 2 points. And this one I am going to use red. X1, Y1, X2, Y2. Let's go ahead and write our slope formula. We're actually going to just substitute. Y sub 2 is 3, but Y sub 1 is also 3. X sub 2 happens to be 20, and X sub 1 happens to be 19. Well, there's a problem here. Well, it's not really a problem, but look what happens. 3 minus 3 is 0, and 20 minus 19 is 1. Anytime you have a 0 in the numerator, 0 divided by anything happens to be 0 as your final answer. So sometimes if you get 0 on the bottom now, that would be called undefined, and you get that later on. There's our 0. Alright, last couple of little, hopefully you could see the red dots. Normally I would connect the dots and use a straight edge and whatever, but I wanted you to visualize these points that are on this grid. And notice that all of the points that are in red hit exactly on a point. So all we got to do is, and we're always going to go from left to right, and we're going to pick any 2 points at random. In this case, we're going to pick a couple of points at random. I'm going to pick this point here that I'm marking with a green arrow, and I'm going to pick this point here, whoops, that I'm marking with the blue arrow. Okay? Alright, now what we're going to do is we're going to figure out how we get from the green arrow, the point where the green arrow, to the one in the, we're going left to right. So what we're going to do is we're going to make some kind of a little triangle here. And we're going to go down and to the right. So if we look at our grid, we went down 3. So we're going to say down 3, and I'm abbreviating. and we're going to go right 2. Okay, anytime you go down, it's negative, and everything to the right is positive. So your slope, by using the rise over run method, would be negative 3 over 2. And this is simply by using the counting method. If you pick any other points, you could also get the same answer. In fact, we'll go ahead and demonstrate that by erasing just a little bit of this. This time, we know it's negative 3 over 2. That we know. So there's no confusion. And now we're going to pick 2 different points. This time, I'm going to pick, I'll go red again. I'm going to use this point here, and I'm going to go down to this point here. Okay, so we're still going to get negative 3 over 2, but it's going to take us a little more effort. We're going to go down, and I'm going to go with the black marker, and then we're going to go right until we hit that point. Okay, so there's our little triangle or angle. It's a right triangle, right angle. So I'm going to go from, let's call this point A, and we'll call this one here point B. To go from A to B, I'm going to go figure out how far down I'm going. I'm going to just count now. 1, 2, 3, 4, 5, 6. So I'm going down 6 and right 4. Okay, so I went down 6 and right 4. Well, down is still negative, and all of the right or left, whatever, is going to be positive. So it's always down and to the right, or up and to the right. In this case, we have negative 6 over 4, but that also reduces down to negative 3 over 2, and that is your final answer. And that's using the counting method. Okay, we'll do another one similar, and this time I'm going to go call this point here point A, and I'll circle that one, and I'm going to pick maybe this point here, call it point B. I could have used the closest one, but in this case I'm going to go up 2 and right 4. So there's my up 2, and there's my right 4. So up 2 and right 4. I'm going to note that. You go up, it's positive, and the right is also positive. So 2/4, positive 1/2. So the slope of the line represented by the red points is 1/2. And that's using the counting method. You don't always have that option, but if you do, use it. All right, now we're going to look at the 4 slope types of linear equations. And all of these lines we're thinking from left to right. In fact, we're going to label them. We're going to call this slope A, first line. Slope B, second line. Slope C, and slope D. And now we're going to go ahead and identify what type of slope we have based on the way the line is shaped or the direction of the line. If the line that you have graphed, and we're going to take example A here, if from left to right the line increases or gets higher, this is a positive slope for line A. Conversely, line B is a negative slope. From left to right, it is going to be, it's going down from left to right. Line C, if it's a flat horizontal line, this has a 0 slope. So that previous slope that we computed where it was a 0, if you were to plot those 2 points and connect them, it would give you a flat vertical line. A horizontal line, my mistake. D is straight vertical. A slope with a line that is it's undefined slope. This is a vertical line. So the vertical line is undefined. The horizontal line is 0. So those are the slope types. All right, last little thing we're going to look at is state the directionals. I use this often because I want students to know how to move from one point to the next. So I have 5 examples, and they are lettered A, B, C, D, E. And I'm going to include an F down here, and this is going to be an undefined slope where we don't have it, where the denominator is 0. So if the slope was in example A, all slope can be thought of as a fraction. In this case, this is actually 2 over 1. Since it's positive 2, you're going to go up 2, and you're going to go to the right 1 unit. Negative 3 now, example B, is negative 3 over 1. So that would be the same as down 3 and right 1. Example C is 2/5, and that's a fraction, but it's positive. And I'm going to abbreviate from here on. 2/5 would be down 2, right 5. Negative 3/4 is down 3, right 4. A 0 slope is straight or flat at a given point now. And we'll talk about that later. Undefined, you would have a straight vertical line. Well, that's a look at computing slopes given 2 points, or possibly the grid or the graph. For more information, always stop by Think Purple Math. Subscribe if you want to, or bookmark it, or what have you. And may the sun shine in your direction. Have a great day, and think